Question 1. In the context of Mr. Thompson inspecting a commercial chiller after a flood, he notices the evaporator coil is heavily saturated and the ambient humidity is high. He wants to ensure proper drying without causing corrosion or microbial growth. Which approach should Mr. Thompson prioritize? A. Increase fan speed to maximize air velocity over the coil immediately. Implement controlled dehumidification using a desiccant or mechanical dehumidifier. C. Apply high heat directly to the coil to accelerate water evaporation. D. Spray disinfectant over the coil and allow natural drying. Answer. Correct answer. B. Explanation. Controlled dehumidification carefully removes moisture while minimizing thermal stress, corrosion, or microbial proliferation. Simply increasing air velocity can redistribute moisture without adequate removal. Applying high heat risks damaging the coil and insulation, and spraying disinfectant without drying leaves residual moisture promoting microbial growth. Using mechanical or desiccant dehumidifiers. HVACR standards for structural drying and safe remediation, ensuring proper moisture reduction before chemical treatments. Question 2. According to recent studies, Rivera is restoring an HVAC system after smoke damage. She notes that accumulation on duct surfaces and fears redistribution during cleaning. What should Rivera do first? A. Open all vents and run the system to flush the ducts. B. Establish containment and use negative air machines before cleaning. C. Apply a mild detergent spray directly to duct surfaces. D. Seal off all ductwork permanently to prevent odor spread. Answer. Correct answer. D. Explanation. Sealing ductwork is not a restoration best practice. It prevents airflow but traps contaminants, potentially worsening odors and mold risk. The correct approach is establishing containment and using negative air machines to prevent contaminant spread. Running the system before containment risks distributing certain smoke throughout the building. Direct detergent application without containment can aerosolize particulates. Effective remediation follows HVACR principles emphasizing containment, filtration, and controlled cleaning. Question 3. Given the circumstances, Mr. Patel detects elevated moisture readings inside a crawl space adjacent to a flooded mechanical room. He must determine the hidden moisture sources before placing air movers. Which method best identifies concealed water? A. Visual inspection alone of accessible surfaces. B. Thermal imaging combined with moisture meters for accurate detection. C. Immediately applying air movers to suspected wet areas. D. Relying solely on relative humidity readings from the air. Answer. Correct answer. C. Explanation. Immediately deploying air movers without detection risks inefficient drying and potential mold growth. Visual inspection may miss hidden pockets behind insulation or under flooring. Relying only on ambient humidity is insufficient. Thermal imaging combined with moisture meters allows accurate identification of concealed moisture, guiding proper equipment placement. This method aligns with HVACR water damage restoration standards and ensures structural drying is targeted, efficient, and prevents secondary microbial contamination. Question 4. While examining a residential split AC unit after sewage backup, Williams notices the refrigerant lines appear oily and contaminated. She must determine the correct sequence of remediation. Which step is most critical first? A. Evacuate the system to remove refrigerant. B. Clean coils with antimicrobial solutions before sealing the system. C. Recover refrigerant and perform thorough system decontamination. D. Charge the system immediately to restore cooling. Answer. Correct answer. B. Explanation. Immediate charging without decontamination is unsafe and can redistribute biological hazards. Evacuation is only safe once the system is clean. Cleaning coils with antimicrobial solutions and proper containment is essential to remove contaminants, oils, and microbial growth. Recovering refrigerant safely aligns with HEPA guidelines, but remediation prioritizes structural and system sanitization. System recharging. Following DRT protocols ensures safety and functional restoration without compromising indoor air quality. Question 5. From a practical standpoint, Mr. Nguyen is restoring HVAC ducts after mold contamination. The ducts are constructed of both flexible and sheet metal segments. Which cleaning approach maximizes safety and effectiveness? A. Use high-pressure water jets for all duct sections. B. Utilize HEPA vacuuming with gentle agitation in all segments. C. Replace only visible sections of ductwork without inspection. D. Spray a concentrated chemical disinfectant and leave it. Answer. Correct answer. B. Explanation. HEPA vacuuming with gentle agitation effectively removes mold spores without damaging materials. High-pressure water risks structural compromise and spreading spores. Replacing only visible sections may leave hidden contamination. Spraying chemicals without prior cleaning leaves mold embedded, reducing efficacy. HRConquer emphasizes physical removal of biohazards, followed by chemical treatment if necessary, ensuring both microbial reduction and structural preservation. Question 6. While evaluating the merits of an SOR's heat pump after flood exposure, HRConquer observes compressor or contamination and corrosion on terminals. What is the most appropriate next step? A. Immediately run the system to test functionality. B. Perform full system evacuation, flush with approved oil, and inspect electrical connections. C. Replace the compressor without investigation. D. Ignore minor corrosion, as the system will self-correct. Answer. Correct answer. C. Explanation. Running the system with contaminated oil risks mechanical failure. Ignoring corrosion compromises electrical safety and reliability. Replacing the compressor without investigation wastes resources if contamination affects other components. The correct approach is full evacuation or flushing and inspection of electrical connections to restore operational integrity and prevent future failure. This follows HEPA handling and HRConquer restoration best practices, ensuring both system performance and safety. Question 7. In light of recent developments, Chen is tasked with odor removal in a facility affected by both smoke and water damage. Which technique best addresses the underlying source rather than masking the odor? A. Masking with fragrance or ozone generators. B. Identifying and removing contaminated materials, then applying targeted neutralizers. C. Increasing airflow to disperse odors. D. Spraying disinfectant in the air ducts only. Answer. Correct answer. B. Explanation. Masking odors does not address microbial or smoke residues. Simply increasing airflow may spread contaminants. Spraying disinfectants in ducts without material remediation leaves odor sources intact. Effective odor removal requires identifying contaminated materials, proper containment, and application of neutralizers after thorough cleaning. HRConquer emphasizes source removal and neutralization over masking, which ensures long-term indoor air quality and prevents secondary contamination. Question 8. Through careful analysis of a flooded commercial rooftop HVAC unit, Mr. Garcia notices that condensate trays are full and insulation is saturated, which is the safest approach to prevent secondary water damage. A. Remove insulation and allow natural drying. B. Drain trays, replace or dry insulation and deploy dehumidification strategically. C. Ignore the insulation as it will dry quickly on its own. D. Pour disinfectant directly into trays to eliminate microbial growth. Answer. Correct answer. C. Explanation. Ignoring insulation risks microbial proliferation and structural degradation. Natural drying without airflow or dehumidification is inadequate. Simply pouring disinfectant fails to remove moisture and can be ineffective against embedded microbial growth. Draining trays, removing or drying insulation, and controlled dehumidification follow HRConquer standards, ensuring complete moisture removal, micro control, and restoration of safe operational conditions in the HVAC system. Question 9. Considering the evidence, Mr. Smith is diagnosing a packaged rooftop unit with unusual airflow patterns after a flood. He wants to confirm if the ductwork has hidden obstructions or leaks. Which method provides the most reliable assessment? A. Measuring static pressure and comparing to design specifications. B. Visual inspection only from accessible grills. C. Listening for air whistling sounds during operation. D. Guessing based on prior experience with similar units. Answer. Correct answer. A. Explanation. Static pressure measurement is a quantifiable method to detect leaks or obstructions, allowing comparison against system design. Visual inspection may miss hidden issues and acoustic assessment is subjective. Guessing based on experience lacks reliability. Using pressure readings aligns with ASHRAE principles and ensures accurate diagnosis of airflow problems. Guiding targeted remediation, balancing, or ductwork restores system efficiency and indoor air quality. Question 10. Based on the information, is Lopez must safely decontaminate a heat pump coil contaminated with biohazards after flood exposure. What is the best practice? A. Apply a strong chemical sanitizer immediately without drying. B. Dry the coil first, then apply antimicrobial treatment following safety guidelines. C. Disassemble the coil and soak in water. D. Replace the coil without treatment. Answer. Correct answer. D. Explanation. Applying chemicals to a wet coil may exacerbate microbial growth. Soaking in water spreads contamination and risks damage. Simply replacing the coil without investigation wastes resources if systemic issues exist. The best practice is controlled drying followed by antimicrobial treatment to eliminate biohazards safely consistent with IWRI protocols. This ensures effective restoration, prevents second contamination, and maintains heat pump performance. Question 11. In the context of Mr. Alvarez responding to a building flooded by a storm, he observes that the air handler insulation is saturated and the return duct has visible mold growth. What should Mr. Alvarez do first to prevent microbial proliferation? A. Immediately turn on the HVAC system to accelerate drying. B. Establish containment, remove contaminated insulation, and initiate controlled dehumidification. C. Spray antimicrobial directly into the duct and leave it running. D. Use high-pressure air to blow moisture out of the ducts. Answer. Correct answer. B. Explanation. Turning on the HVAC system or using high-pressure air without containment spreads mold and contaminants. Spraying antimicrobials on wet surfaces is ineffective because moisture promotes microbial growth and may aerosolize spores. The correct procedure involves establishing containment to prevent spread, removing water-damaged materials like insulation, and using controlled dehumidification. This approach aligns HVAC standards, targeting both moisture and microbial reduction safely while protecting air quality and structural integrity. Question 12. From a practical standpoint, Kim is restoring a commercial rooftop unit after a flash flood. She finds that the condenser fins are heavily clogged with debris and the refrigerant charge may be compromised. Which approach best ensures both system safety and performance? A. Immediately flush the refrigerant system without inspecting for contamination. B. Clean condenser fins, perform leak detection, evacuate the system, and recharge with proper refrigerant. C. Replace the entire unit without inspection. D. Increase airflow through the unit to compensate for restricted heat exchange. Answer. Correct answer. C. Explanation. Simply increasing airflow does not address debris or contamination and may damage the unit. Flushing the system without prior inspection risks spreading contaminants into the compressor. Replacing the unit without inspection is a last resort measure but may be wasteful. The most comprehensive approach is cleaning the condenser, performing leak checks, evacuating non-condensables and moisture, and recharging with refrigerant. Following EPA and DRT guidelines ensures operational integrity and safe restoration. Question 13. Considering the evidence, Mr. Sanders notices that after a sewage backup, the heat pump duct system shows signs of odor and microbial growth in concealed joints. Which diagnostic step provides the most reliable assessment before remediation? A. Visual inspection of only accessible duct surfaces. B. Air sampling combined with moisture mapping and infrared thermography. C. Relies solely on occupant complaints of odor intensity. D. Spraying disinfectant immediately into the ducts. Answer. Correct answer. A. Explanation. Solely relying on occupant complaints or immediate spraying does not provide accurate contamination mapping. Visual inspection alone of accessible surfaces may miss hidden pockets, but is the initial step to guide further testing. Combining inspection with moisture mapping and infrared imaging is ideal for full assessment. RT best practices emphasize confirming contamination and moisture sources before initiating cleaning or chemical treatment to ensure targeted remediation, minimize cross-contamination, and protect indoor air quality. Question 14. While examining a residential AC system after water intrusion, is Lopez detects oil and particulate contamination in the compressor and evaporator coil. What is the most critical next step to protect system integrity? A. Apply a chemical sanitizer immediately and restart the system. B. Recover refrigerant, flush the system with approved oil and decontaminate all components. C. Replace the compressor without investigation. D. Operate the unit at low speed to flush out contaminants. Answer. Correct answer. D. Explanation. Operating a contaminated system risks mechanical failure and spreading biohazards. Immediate chemical application without drying and flushing is unsafe. Replacing the compressor without examining the full system may miss residual contamination. Correct restoration involves recovering refrigerant safely, flushing with compatible oil, and decontaminating all affected components according to EPA refrigerant handling rules, ART protocols. This ensures the system operates safely and microbial or particulate contamination is minimized. Question 15. Under the assumption that a commercial heat exchanger suffered smoke and infiltration, Mr. Chen wants to remove contaminants without damaging fin surfaces. Which method should he apply? A. High-pressure water jet cleaning. B. HEPA vacuuming with gentle agitation followed by chemical treatment if needed. C. Soaking in bleach solution overnight. D. Running the system to circulate air through the fins. Answer. Correct answer. B. Explanation. High-pressure water or chemical soaking risks structural damage and may not fully remove soot. Running the system circulates contaminants, worsening indoor air quality. HEPA vacuuming with careful agitation physically removes particulates without harming fin integrity. If residual contamination exists, targeted chemical treatment is applied afterward. This approach complies with HVACR standards emphasizing contamination removal and preservation of system performance while protecting occupants. Question 16. Taking into account recent flood damage in an industrial facility, is Martinez observes unusual refrigerant readings in a packaged chiller. What should she prioritize to avoid operational failure? A. Just system pressures based solely on gauge readings. B. Evacuate the system to remove non-condensables and moisture, inspect components, and recharge properly. C. Increase the refrigerant charge arbitrarily to compensate. D. Run the system at partial load to test capacity. Answer. Correct answer. C. Explanation. Adjusting refrigerant arbitrarily or running the system under abnormal conditions risks compressor damage, system inefficiency, and potential safety hazards. Correct procedures require evacuating non-condensables and moisture to restore thermodynamic efficiency, inspecting system components for contamination, and recharging with the correct refrigerant quantity. This aligns with EPA regulations, refrigeration practices, and HVACR restoration guidelines, ensuring both safety and reliable performance after flood events. Question 17. In what ways can Mr. Rodriguez assess hidden moisture inside a flood-damaged crawl space prior to installing drying equipment? A. Measure only ambient relative humidity. B. Visual inspection combined with moisture meters and thermal imaging. C. Deploy air movers immediately to accelerate evaporation. D. Wait for natural drying and inspect later. Answer. Correct answer. B. Explanation. Ambient humidity alone may not detect concealed moisture, and deploying air movers without mapping can spread mold or prolong drying. Waiting for natural drying is inefficient and risks microbial growth. Combining visual inspection, moisture meters, and thermal imaging allows precise identification of hidden wet areas, guiding correct equipment placement. This methodology adheres to HVACR standards and ensures effective structural drying while preventing secondary contamination and damage. Question 18. During the process of restoring a mold-affected HVAC duct system, Johnson wants to prevent cross-contamination while working. Which containment strategy is most appropriate? A. Open all supply and return vents to maximize airflow. B. Seal work areas with plastic barriers and use negative air machines to maintain pressure differentials. C. Apply disinfectant in affected areas without physical containment. D. Work sequentially from one room to another without barriers. Answer. Correct answer. D. Explanation. Working without containment risks spreading spores throughout the building. Opening vents or applying chemicals without barriers can aerosolize contaminants. Proper containment requires sealed work areas with negative air pressure to prevent cross-contamination following HRConquer guidelines. This ensures the safety of occupants, workers, and unaffected areas while allowing effective cleaning and mold remediation. Question 19. With respect to odor control in a water-damaged facility, Mr. Allen observes persistent smoke and microbial odors in HVAC components. Which approach addresses the root cause effectively? A. Mask odors with fragrances or ozone generators. B. Remove contaminated materials and apply targeted neutralizers after drying. C. Increase ventilation without removing contaminants. D. Spray disinfectants in ducts while the system is running. Answer. Correct answer, A. Explanation. Masking odors temporarily hides the problem but does not remove the microbial or smoke residues causing the odor. Increasing ventilation or spraying chemicals without addressing contaminated materials is ineffective. The proper remediation sequence is removing sources of contamination, drying affected areas, and applying neutralizers or odor-specific treatments consistent with HRConquer. This ensures long-term mitigation, indoor air quality protection, and compliance with disaster restoration best practices. Question 20. Through the lens of a flood-damaged residential heat pump, Brian identifies water-saturated insulation around refrigerant lines. What is the safest restoration method? A. Allow natural drying while leaving insulation in place. B. Remove and replace damaged insulation, followed by controlled dehumidification. C. Spray chemical disinfectant over wet insulation. D. Wrap wet insulation with plastic to prevent further moisture ingress. Answer. Correct answer, B. Explanation. Leaving wet insulation risks microbial growth and structural damage. Spraying chemicals on wet insulation does not remove moisture and can exacerbate contamination. Wrapping wet insulation traps water, promoting mold. Removing damaged insulation and using controlled dehumidification ensures moisture is eliminated, materials are safe, and system efficiency is restored. This follows HRConquer and S Guide, focusing on structural drying, microbial control, and safe restoration practices. Question 21. From multiple perspectives, Mr. Harris is inspecting a commercial chiller that sustained floodwater intrusion. He notes that the compressor oil is cloudy and residual moisture is present in the suction line. What is the most critical next step? A. Run the system to see if the compressor operates normally. B. Recover refrigerant, evacuate non-condensables, and flush the system with approved oil. C. Replace only the oil without evacuating the system. D. Spray an antimicrobial into the compressor compartment. Answer. Correct answer, B. Explanation. Running the system with contaminated oil risks mechanical failure and spreading contaminants. Simply replacing oil without evacuation leaves moisture and non-condensables in the system, reducing efficiency and causing corrosion. Spraying antimicrobials does not protect mechanical components. Recovery, evacuation, and flushing ensure system integrity, align with EPA refrigerant handling regulations, and follow area principles for restoring both mechanical function and safe operation after water intrusion. Question 22. When analyzing a flooded residential air handler, Patel finds water pooled under the evaporator coil and wet insulation in the plenum. Which remediation approach is most effective? A. Leave insulation to dry naturally while running the system. B. Remove and replace wet insulation, drain water, and apply controlled dehumidification. C. Spray disinfectant over wet areas while operating the unit. D. Increase fan speed to evaporate moisture faster. Answer. Correct answer, C. Explanation. Running the system or increasing fan speed with wet insulation risks microbial growth and secondary damage. Spraying disinfectants without proper drying is insufficient and may aerosolize contaminants. The correct procedure involves removing saturated insulation, draining standing water, and applying controlled dehumidification to remove moisture effectively, following HRConquer and S guidelines. This method wall proliferation maintains structural integrity and ensures safe indoor air quality during restoration. Question 23. In light of recent developments, Mr. Nguyen observes that a water-damaged rooftop unit's condensate pan has standing water, while ductwork shows minor contamination. What should he do first? A. Apply chemicals to the ductwork and run the system immediately. B. Drain the condensate pan, remove standing water, and establish negative air for containment. C. Ignore the pan since it will evaporate naturally. D. Replace the entire duct system immediately. Answer. Correct answer. D. Explanation. Ignoring standing water risks microbial growth, and running the system without containment spreads contamination. Applying chemicals alone does not address moisture. Immediate duct replacement is unnecessary if contamination is limited. The correct approach is draining the pan, removing residual water, and establishing negative air and containment to prevent cross-contamination, aligning with DRT standards for drying and microbial control. Question 24. In the modern context of odor removal after a flood, Rodriguez wants to eliminate persistent smoke and microbial odors from HVAC components. Which method addresses the underlying problem? A. Mask odors using ozone or air fresheners. B. Remove contaminated materials, dry affected areas, and apply targeted neutralizers. C. Increase airflow without remediation to disperse odors. D. Apply disinfectant sprays directly into ducts while the system runs. Answer. Correct answer. B. Explanation. Masking or increasing airflow only temporarily addresses odors and may spread contaminants. Disinfectants alone do not remove odor sources. Effective odor control requires removing contaminated materials, drying all affected components, and applying neutralizers. This approach prevents recurrence of odors, eliminates microbial sources, and aligns with HRConquer standards for safe and effective odor remediation. HVAC systems after disaster exposure. Question 25. Considering the evidence Brown detects uneven airflow and high static pressure in a commercial duct system after water exposure, what is the most reliable diagnostic step? A. Visual inspection of accessible grills only. B. Measure static pressure and airflow at multiple points to detect obstructions or leaks. C. Listen for whistling sounds in the ducts. D. Operate the system at maximum speed to see if airflow normalizes. Answer. Correct answer. C. Explanation. Visual inspection alone may miss hidden leaks or obstructions, and relying on whistling sounds is subjective and unreliable. Operating at maximum speed can exacerbate issues. Measuring static pressure and airflow at multiple locations provides quantifiable, reproducible data for detecting blockages or leaks, allowing targeted remediation. This approach aligns with ASHRAE principles for system diagnosis and HRConquer best practices for restoring HVAC functionality and indoor air quality after flooding. Question 26. In what ways can Allen ensure proper microbial control when restoring a mold-contaminated air handler? A. Run the unit to dry the coil naturally before cleaning. B. Establish containment, physically remove mold, and apply biocide as needed. C. Apply high-pressure air to dislodge mold spores. D. Mask odors with fragrances after minimal cleaning. Answer. Correct answer. A. Explanation. Running the system on a contaminated coil without containment spreads spores, risking occupant exposure. High-pressure air may aerosolize mold, and masking odors does not remove microbial sources. The correct method involves containment, careful removal of visible mold, and selective biocide application after moisture reduction. This aligns with HRConquer standards and ensures safe, effective remediation, protecting indoor quality and preventing secondary contamination throughout the HVAC system. Question 27. Through careful analysis of a flood-damaged heat pump, Johnson notes corrosion on electrical terminals and moisture on the control board. Which is the most critical immediate action? A. Power up the system to test for operational issues. B. Isolate power, remove moisture, inspect for damage, and repair or replace affected components. C. Ignore minor corrosion and continue restoration. D. Apply a protective coating and restart the unit. Answer. Correct answer. B. Explanation. Applying power to wet or corroded components risks electrical shock, fire, and permanent system damage. Ignoring corrosion or using protective coatings without inspection leaves hazards unmitigated. Proper restoration requires de-energizing the system carefully, removing moisture and assessing electrical and control components for damage. Repairs or replacements should follow, ensuring both personnel safety and operational integrity consistent with DRT and OSHA electrical safety standards. Question 20. Given the circumstances, Chen is tasked with drying a flood-affected crawl space under a commercial building. She needs to maximize efficiency without promoting mold growth. Which approach is best? A. Deploy air movers randomly without mapping moisture. B. Use a strategic layout of air movers and dehumidifiers guided by moisture mapping. C. Allow natural evaporation while occasionally opening windows. D. Apply disinfectant sprays before drying. Answer. Correct answer, D. Explanation. Random placement of drying equipment is inefficient and may leave hidden wet areas. Natural evaporation is slow and allows microbial growth. Applying disinfectants before moisture removal is ineffective and may trap moisture. The correct method uses moisture mapping to identify wet zones, then strategically places air movers and dehumidifiers to accelerate drying while preventing mold. This approach aligns with it standards for structural drying and controlled microbial management. Question 29. Across different scenarios, Garcia detects moisture intrusion in a commercial chilled water system causing high humidity in a mechanical room. What is the most effective first step for system restoration? A. Increase cooling output to condense moisture. B. Isolate water damaged components and deploy controlled dehumidification. C. Spray disinfectant throughout the system while operational. D. Ignore minor humidity fluctuations as temporary. Answer. Correct answer, A. Explanation. Ignoring or spraying chemicals in a water-damaged system without drying does not mitigate microbial growth. Increasing cooling output may not remove moisture effectively and can stress equipment. The correct step is isolating affected components, removing water, and using controlled dehumidification to lower humidity to safe levels. This aligns with HVACR standards, ensuring moisture removal, micro control, and system restoration without further damage. Question 30. When faced with a flood-damaged residential split AC system, Lopez observes standing water in the condensate pan and microbial growth on coil fins. Which is the proper remediation procedure? A. Drain the pan, clean coils with antimicrobial, and apply controlled dehumidification. B. Run the system to evaporate water naturally. C. Spray disinfectant and leave the system running. D. Ignore minor contamination since AC operation will dry components. Answer. Correct answer, B. Explanation. Onning the system with standing water and microbial contamination risks spreading spores and damaging the unit. Spraying disinfectant alone does not remove moisture, and ignoring contamination allows microbial growth. Proper remediation involves draining standing water, applying controlled dehumidification, and cleaning coils to remove contaminants. This procedure follows HVACR standards for safe restoration, ensuring effective moisture removal, microbial control, and restoration of system efficiency.